At 6:15 on the morning of June 6, 1944, the English Channel was quiet. A thin fog clung to the surface of the water, softening the horizon where sea met sky. Far offshore, engines idled, thousands of them. The sound carried faintly across the waves, a low mechanical murmur rising and falling with the tide. High above the beach, set into the chalk bluffs of Normandy, a young German soldier crawled forward inside a concrete bunker. His name was Hinrich Severloh. He was 20 years old. He had grown up on a farm in Lower Saxony. Before the war, his world had been fields, animals, and long days of physical work. He had been drafted in 1942, trained as an artilleryman, then reassigned to an infantry unit guarding the French coast. He had never fired a weapon in combat. He had never seen an enemy face to face. Now, he lay behind a machine gun overlooking Omaha Beach. The position was known as Widerstands Nest 62, Resistance Nest 62, one of dozens of fortified strongpoints built into the bluffs, designed to overlap fields of fire and turn the beach below into a killing ground. Severloh's bunker sat roughly 40 meters above sea level. From its narrow firing slit, the entire eastern sector of Omaha Beach was visible. Nearly 2,000 meters of open sand, no trees, no buildings, no cover. Beside him, stacked neatly against the wall, were metal ammunition boxes, thousands of rounds of 7.92 millimeter ammunition, more than he could count, more than he could imagine firing. The machine gun in front of him rested on its mount, its barrel pointed toward the dark water line. Severloh checked it one last time. The belt was seated, the barrel locked, the sights aligned low, where the waves would soon break. He had fired thousands of rounds during training. He knew the drill by muscle memory: load, aim, fire, change barrel, repeat. What he did not know, what no one on that beach fully understood yet, was that this machine gun was unlike any other weapon that had come before it. Below him, the sea began to move. Dark shapes emerged from the fog. At first they were indistinct, almost unreal, shadows sliding across the water. Then engines grew louder, hulls became visible, ramps, antennas, rows of men standing shoulder to shoulder inside the landing craft. This was the largest invasion fleet ever assembled. More than 5,000 ships, 11,000 aircraft, 156,000 Allied soldiers moving toward the coast of occupied France. At approximately 6:30 a.m., the first landing craft reached the shallows. The ramps dropped. American soldiers spilled forward into the surf, weighed down by 60 pounds of gear. Many fell immediately. Others waded through chest-deep water, rifles held overhead, packs dragging them under. The beach offered no protection. The bluffs loomed above them, silent and unseen. Severloh watched through his sights. For a moment, he hesitated. Then he pulled the trigger. The machine gun erupted, not in bursts, not in a staccato rhythm like the weapons he had trained with. This sound was different, continuous, tearing, a single unbroken scream that filled the bunker and echoed off the cliffs. The gun fired at a rate so high that individual shots could no longer be distinguished. The human ear could not separate them. It was not a series of explosions. It was a sound, like fabric being ripped apart under enormous strain. Men fell in the water below. Then more. The surf churned. Equipment floated free. The lines of advancing soldiers collapsed into confusion. Severloh fired in controlled sweeps, moving the barrel slightly left, then right, keeping the waterline covered. His assistant fed belt after belt into the weapon. When the barrel grew too hot, they changed it. Another slid into place. The firing resumed. This continued for hours. By the end of the day, Omaha Beach would be soaked in blood. Thousands of men would be dead or wounded. And one machine gun position, this one, would become one of the most lethal points on the entire invasion front. Allied soldiers would give the weapon a name. They would call it Hitler's buzzsaw. But the story of that sound did not begin on a French beach. It began years earlier, far from the front lines, in a small German factory that did not build weapons at all. It built lanterns. For the men landing on Omaha Beach, the machine gun fire felt overwhelming, unstoppable, as if the defenders possessed an endless supply of weapons and ammunition. In reality, Germany had a problem, a serious one. At the start of the war, the German army believed it had solved one of modern warfare's most difficult challenges: how to equip infantry for every kind of battle with a single machine gun. That weapon was the MG44. Introduced in 1934, it was unlike anything the world had seen. The German military called it an Einheitsmaschinengewehr, a universal machine gun. One design meant to fill every role on the battlefield. On its bipod, it served as a light machine gun, advancing with infantry. Mounted on a tripod, it became a medium machine gun capable of accurate, sustained fire at long range. With different mounts, it could be installed in tanks, armored vehicles, even aircraft. One weapon, one training program, one ammunition supply, one doctrine. On paper, it was brilliant. The MG34 was fast, accurate, and adaptable. It fired nearly twice as fast as most Allied machine guns and featured a quick change barrel that allowed continuous fire. Its sights were precise. Its machining was immaculate. German officers were proud of it. Many believed it gave them a decisive edge. But the MG34 had been designed for excellence, not for war on an industrial scale. Every major component of the weapon was machined from solid steel. Not stamped, not pressed, machined. The receiver alone was milled from a single block of high-grade steel. The bolt assembly consisted of dozens of finely fitted parts. Each component required skilled labor, precision tools, and time. A great deal of time. To produce a single MG34 required roughly 150 man-hours of work. In practical terms, that meant a skilled machinist might complete one gun per month. The cost reflected that effort. Each MG34 cost more than 300 Reichsmarks to manufacture, more than 2 months' wages for an average German factory worker. It also consumed enormous quantities of high-quality steel alloys, many of which Germany had to import. As Germany expanded its army in the late 1930s, planners began to do the math, and the numbers didn't work. Germany was preparing for a long war, one that would demand millions of soldiers and tens of thousands of machine guns. But the country did not have enough skilled machinists to produce them, not without pulling labor away from aircraft engines, tanks, artillery, and every other piece of modern warfare that also demanded precision manufacturing. The MG34 was too slow to build, too expensive, and too delicate. In the dust of North Africa, it jammed. In the mud of the Eastern Front, it failed. Fine tolerances that made it accurate in testing made it unreliable in the field. By 1937, the German Army Weapons Office reached a quiet but unavoidable conclusion. The MG34 was a technological triumph and a strategic liability. Germany needed a new machine gun, not one that was more precise, not one that was more elegant, but one that could be built quickly, cheaply, and in enormous numbers, without sacrificing battlefield effectiveness. In February of that year, the Army issued a request that would quietly reshape modern warfare. They wanted a universal machine gun that could match the MG34 in combat performance, but be dramatically easier to manufacture. 3 companies were invited to submit designs. 2 of them were exactly who you would expect, and 1 of them was not. The first 2 companies invited to compete for Germany's new machine gun were no surprise at all. They were established arms manufacturers, firms with decades of experience designing weapons for the German military. Their engineers understood ballistics, metallurgy, recoil systems, and combat requirements. They knew how machine guns were supposed to look, feel, and function. Their proposals reflected that knowledge. Both designs were evolutions of existing weapons, refinements, improvements, familiar mechanisms made slightly better, slightly cheaper, slightly easier to produce. The third company was different. Its name was Metall- und Lackwarenfabrik Johannes Grossfuss. It was located in Döbeln, a small provincial town in Saxony, a place most Germans had never heard of. The factory did not produce weapons. It did not produce military equipment of any kind. It made lanterns, pressed steel housings, simple consumer goods, items designed to be manufactured quickly, cheaply, and in enormous numbers. The company's expertise was not in firepower. It was in production. When Grossfuss received the Army's request, the company did not turn it down. Instead, it assigned the project to a 33-year-old mechanical engineer named Werner Gruner. Gruner was not a soldier. He had never served in the military. He had never fired a machine gun in combat. What he understood was manufacturing. He had studied mechanical engineering at the Technical University of Dresden, specializing in mass production techniques. His doctorate focused not on weapons, but on how complex objects could be made efficiently by unskilled labor using simple processes. At Grossfuss, he had spent years designing stamped steel products, parts formed by pressing sheet metal into shape instead of cutting them from solid blocks. To traditional weapons designers, this background was a liability. To Gruner, it was the point. Before he began designing anything, Gruner made an unusual decision. He enrolled in a German army machine gun course. For weeks, he trained alongside infantry soldiers. He learned how machine gunners carried their weapons, how they set up firing positions, how ammunition belts were fed, how overheated barrels were changed under stress. He listened more than he spoke. Veteran gunners complained about the MG42's sensitivity to dirt, about parts that were too delicate, about jams that occurred at the worst possible moment. Gruner took notes. When the course ended, he returned to Dublin and began working from first principles. Instead of asking how to build a better machine gun, he asked a different question. How do you build a machine gun that can be made by the tens of thousands? Traditional weapons manufacturing began with a block of steel. Skilled machinists removed material until a finished part emerged. The process was slow, expensive, and wasteful. Much of the steel ended up as shavings on the factory floor. Gruner proposed the opposite. He would start with flat sheets of steel and press them into shape. Receivers, housings, and structural components would be stamped, riveted, and spot welded. Only the most critical parts, the barrel, the bolt, a handful of high-stress components, would be machined. The idea shocked the weapons establishment. Stamped steel was seen as crude, inferior, suitable for lanterns, not machine guns. Critics argued that such parts would crack, warp, or fail under the enormous forces generated by automatic fire. Gruner disagreed. Stamped parts, when designed correctly, could flex slightly under stress instead of breaking. They used less material. They could be produced rapidly by semi-skilled workers, and most importantly, they could be made in numbers Germany desperately needed. By late 1937, all three companies submitted their proposals. Two looked familiar. One looked like nothing the Army had ever seen before. Against expectations, the lantern makers were chosen for further development. Germany had placed the future of its infantry firepower in the hands of a factory that had never built a weapon, and an engineer who believed the real battlefield was the production line. Werner Gruner's design did not look impressive at first glance. It lacked the polished finish of traditional German weapons. There were no beautifully milled surfaces, no intricate machining meant to signal craftsmanship. Much of the gun appeared plain, industrial, almost crude. To experienced weapons inspectors, it looked wrong. The receiver was formed from stamped steel. Plates were riveted and welded together instead of being cut from solid metal. The tolerances were visibly looser than those of the MG42. Parts that would normally be machined had been simplified or eliminated entirely. Many evaluators assumed it would fail. Automatic weapons endure enormous stress. Every shot produces intense heat, vibration, and pressure. Multiply that by hundreds of rounds per minute, and even minor weaknesses become catastrophic. Conventional wisdom held that only precision machining could survive that punishment. Gruner believed the opposite. Instead of fighting stress, he designed the weapon to absorb it. Stamped components flexed slightly under load rather than cracking. The looser tolerances allowed dirt, sand, and carbon fouling to pass through the mechanism instead of stopping it. The most radical departure lay inside the gun. Rather than the rotating bolt used by the MG42, Gruner's weapon employed a roller locking system. Two hardened steel rollers engaged recesses in the barrel extension, holding the bolt closed at the moment of firing. Only after pressure dropped to safe levels were the rollers forced inward, unlocking the action and cycling the next round. The system was strong, simple, and perfectly suited to stamped construction. By early 1938, the first prototypes were ready. They were sent to the proving grounds. The initial tests were not gentle. The weapon was buried in sand, dragged through mud, exposed to dust, cold, and heat. It was fired until the barrel glowed, then fired some more. Barrels were changed. Belts were fed as fast as hands could move. Inspectors waited for failure. Instead, the gun kept firing. Where the MG34 choked on grit, the new weapon continued cycling. Where finely machined parts would seize, the stamped components flexed and recovered. Jams were rare, breakages rarer still. Problems did emerge. The feed system required refinement. Some parts showed accelerated wear. The barrel change mechanism needed to be faster. Gruner and his team returned to Dobeln and went back to work. They did not redesign the weapon to make it more elegant. They redesigned it to make it survive. By early 1939, the improved prototype, now designated the MG39, was ready for extended trials. The results were impossible to ignore. The MG39 required roughly half the labor hours of the MG34. It used significantly less steel. It could be produced by semi-skilled workers using simple presses instead of precision milling machines. And it worked. In fact, it worked better than the weapon it was meant to replace. The German army had asked for a machine gun that matched the MG34's performance. What Gruner delivered was a machine gun that exceeded it. The final version of the weapon entered production in early 1942. It received a simple designation, Maschinengewehr 42. MG42. On paper, it looked like an incremental improvement, lighter than the MG34, cheaper to build, easier to maintain. None of that prepared anyone for what happened when it was fired. The MG42's rate of fire was unlike anything infantry soldiers had encountered. Most machine guns of the era fired between 400 and 600 rounds per minute. Even the MG34, considered fast for its time, fired at roughly 850. The MG42 fired at 1,200 rounds per minute. Some variants went even higher. At that speed, the human ear could no longer distinguish individual shots. The brain could not process them as separate sounds. Instead of a familiar staccato burst, the MG42 produced something else entirely. A continuous tearing noise. It sounded like heavy fabric being ripped apart under tension. Others compared it to a buzzsaw cutting through wood. On every front, soldiers struggled to describe it, and none of them forgot it once they heard it. British troops revived an old First World War nickname and called it the Spandau. American soldiers gave it a new one. They called it Hitler's buzzsaw. The sound carried farther than the bullets themselves. Men who had never seen the weapon learned to recognize it instantly. It cut through the noise of battle, through artillery, through explosions, through shouted orders. Before soldiers understood what the MG42 could do, they felt it. The German army had not chosen this rate of fire by accident. Pre-war studies had examined combat footage and battlefield reports from the First World War. Analysts concluded that enemy soldiers were usually exposed for only brief moments, a second or two while moving between cover. The solution was simple and brutal. Put as many bullets as possible into that moment. At 1,200 rounds per minute, the MG42 delivered twice the bullet density of Allied machine guns. In the fraction of a second when a target appeared, the beaten zone filled instantly. This had consequences. The MG42 consumed ammunition at an astonishing rate. Sustained fire could empty belts in seconds. Barrels overheated quickly, glowing red under prolonged use. But these problems had been anticipated. The MG42 featured a rapid barrel change system that allowed a trained gunner to swap barrels in under 6 seconds. Wearing an asbestos glove, the gunner released a side latch, pulled the burning hot barrel free, and slid a fresh one into place, often without ever lifting his eyes. From the battlefield, the feed mechanism was equally ruthless in its efficiency. A roller-driven system inside the top cover pulled belts smoothly at extreme speed, advancing each round with mechanical certainty. Where other machine guns shook themselves apart under similar stress, the MG42 thrived. By mid-1942, it reached the front lines. Its first major combat use came in North Africa during the fighting against British forces in Libya. Almost immediately, reports began filtering back. The new machine gun was devastating. British units encountered defensive positions that seemed impossibly dense with fire. Assaults stalled. Advancing troops were pinned down before they could even identify where the shots were coming from. The sound alone was enough to freeze men in place. By the end of the year, the MG42 was being issued on every front: Russia, Italy, France. German infantry tactics adapted quickly. The machine gun became the center of the squad. Riflemen existed to protect it, feed it, and keep it firing. Everything else was secondary. The MG42 was no longer just a weapon. It was the battlefield. The MG42 did not simply change how battles sounded, it changed how armies fought. Before the war, most militaries treated the machine gun as a support weapon. Infantry squads were built around riflemen. The machine gun existed to assist them, to pin the enemy down while the real fighting was done elsewhere. The German army reversed that logic. With the MG42, the machine gun became the center of gravity. A standard German infantry squad was no longer built around individual shooters. It was built around a single machine gun team. Everything else existed to serve it. The gunner controlled the weapon and selected targets. His assistant fed ammunition, watched for threats, and stood ready to take over instantly if the gunner fell. Another soldier carried the tripod for sustained fire. Others hauled spare barrels, tools, and belts of ammunition. Every man in the squad understood the priority: keep the gun firing. This doctrine worked, but it came at a cost. At 1,200 rounds per minute, ammunition disappeared at an astonishing rate. A single minute of sustained fire could burn through an entire squad's carried supply. Defensive positions had to be stockpiled in advance. Resupply operations prioritized machine gun ammunition above nearly everything else. German logistics strained to keep pace. Barrels wore out quickly. Crews trained endlessly on barrel changes, timing their swaps before overheating could destroy accuracy, or the weapon itself. Gunners learned to feel heat through gloves, to sense when metal was about to fail. The MG42 demanded discipline. It also demanded emotional distance. The weapon's speed made individual shots meaningless. The gunner did not aim at men. He aimed at areas, lanes of advance, gaps between cover, places where movement might appear. When the gun fired, bodies simply fell into those zones. Veterans later described how the sheer volume of fire forced the mind to retreat. Targets became shapes, motion, abstract problems to be solved mechanically. This was not unique to German soldiers, but the MG42 accelerated the process. It made killing efficient enough that human perception struggled to keep up. On the Eastern Front, entire Soviet assaults were shattered before they could close the distance. In Italy, MG42s swept mountain passes and approaches with sustained fire that halted attacks for months at a time. In Normandy's hedgerow country, narrow lanes became natural kill zones. A single well-placed MG42 could dominate hundreds of meters of terrain. Allied soldiers learned to recognize the sound instantly and to react without thinking. Dive for cover, freeze, crawl, wait. The weapon shaped behavior on both sides of the line, and nowhere would that reality be felt more brutally than on a strip of sand in northern France. Omaha Beach was waiting. By the time the sun rose higher over Omaha Beach, the invasion was in danger of failing. The carefully planned landings had collapsed into chaos. Units were scattered, officers were dead or wounded, radios lay drowned in the surf, tanks meant to support the infantry burned on the sand or sat uselessly offshore. Pinned flat against the beach, American soldiers hugged whatever cover they could find: steel obstacles, shell craters, the bodies of men who had fallen moments earlier. Above them, the bluffs remained largely intact, and inside those bluffs, the MG42s kept firing. At Widerstandsnest 62, Hinrich Severloh had lost all sense of time. He no longer remembered individual moments, only repetition: load, fire, barrel change, fire again. The assistant's hands moved automatically. Ammunition belts vanished into the gun as fast as they could be fed. When one barrel overheated, another replaced it. When that one glowed, it too was swapped out. The process was relentless. Below, the waterline became a killing zone. Men emerging from the surf were cut down almost instantly. Others fell before their boots touched sand. Those who made it to the beach crawled forward inch by inch, pinned by fire they could barely locate. The MG42 did not need to be accurate in the traditional sense. It needed only to fill space. Its fire swept across lanes of approach, saturating them with bullets faster than bodies could move through. Every burst erased movement, every pause invited death. For the defenders, this was doctrine made real. For the attackers, it was something else entirely. Veterans would later describe the sensation of being hunted by a machine. Not a man, not even a position. A presence that punished movement instantly and without warning. The sound of the MG42 dominated everything. It echoed off the cliffs, rolled across the sand, and merged into a single continuous roar. Some soldiers froze, others tried to run and were cut down. A few, by instinct or desperation, pushed forward anyway. Slowly, painfully, small groups began to move up the beach. Naval gunfire found its mark. Destroyers crept dangerously close to shore, firing point-blank into the bluffs. Smoke obscured firing slits. Engineers blew gaps in the wire. The machine gun positions were not silenced all at once. They were taken one by one. By early afternoon, American troops had broken through the defenses and moved inland. Omaha Beach was secured at a cost measured in blood. More than 2,000 Americans lay dead or wounded. At WN-62, Severloh's gun finally fell silent. Years later, he would claim to have fired tens of thousands of rounds that morning. The exact number remains debated. What is not debated is the effect. One machine gun, used as it had been designed, had held back an army. The MG42 had done exactly what it was built to do. And when the war ended, the world took notice. When the war ended, the shooting stopped. But the MG42 did not disappear. Across Europe, Allied intelligence teams collected German weapons for study: tanks, aircraft, missiles, small arms. Among them were thousands of MG42s, many still serviceable, many still terrifyingly effective. The Allies approached the weapon without ideology. They treated it as a problem to be understood. American, British, and Soviet engineers disassembled the MG42 piece by piece. They measured tolerances, tested materials, fired captured examples until barrels burned out and bolts cracked. What they found was unsettling. The MG42 was not just effective by German standards, it was objectively superior. Its stamped construction had not weakened it. Its loose tolerances had not reduced accuracy in the role that mattered. Its roller locking system proved durable, elegant, and adaptable. Most importantly, the MG42 solved a problem every modern army faced. How do you produce overwhelming firepower, quickly, cheaply, and at scale? No Allied machine gun matched it, not the American Browning, not the British Vickers, not the Soviet Maxim. Each of those weapons had strengths, each had proven reliable. But all were heavy, slow to manufacture, or rooted in pre-war assumptions. The MG42 belonged to a different era. So the Allies did what militaries have always done: they copied it. In the United States, engineers attempted to adapt the MG42's principles to American manufacturing and doctrine. The result, after years of experimentation, was the M60, a machine gun that borrowed heavily from the MG42's feed system and operating mechanism. It was never a perfect weapon, but its lineage was unmistakable. In Western Europe, the influence was even clearer. The Belgian FN MAG, later adopted by dozens of countries, took the MG42's core ideas and refined them. It became one of the most successful machine guns of the Cold War. In Germany itself, the story was almost direct. The Bundeswehr reintroduced the weapon as the ETA MG3, a modernized MG42 rechambered for NATO ammunition. Many parts remained interchangeable with wartime guns. Some production tooling traced its origins directly back to Döbeln. The war had ended, the design had not. By the 1960s, soldiers across the world were carrying machine guns descended from a weapon first conceived in a lantern factory 3 decades earlier. They did not call it Hitler's buzzsaw anymore, but they still heard the same sound. When the war was over, the MG42 did not haunt battlefields anymore. It haunted people. Hinrich Severloh returned to Germany a different man. He went back to civilian life, took work where he could find it, tried to build something resembling normality. Outwardly, he succeeded. Inwardly, the beach never left him. For decades, he carried the memory of Omaha with him, the sound, the motion, the endless repetition. He later spoke of nights without sleep, of moments when ordinary noises snapped him back into that bunker above the surf. He did not celebrate what he had done. He struggled to live with it. Werner Gruner's war ended very differently. He was never tried as a war criminal. He had not designed a weapon out of ideology or hatred. He had solved a technical problem placed in front of him, and then watched the solution take on a life of its own. After the war, Gruner became a respected academic. He taught engineering. He wrote textbooks on manufacturing and production efficiency. His lectures focused on process, materials, and design, not on weapons. Students remembered him as precise, reserved, careful with words. He rarely spoke about the MG42. Two men, one pulled the trigger, the other designed the system that made it possible. Neither escaped the consequences. Years later, Severloh met American veterans who had landed on Omaha Beach, men who had once been on the opposite side of his sights. They spoke not as enemies, but as survivors. Shared memories replaced accusations. Silence replaced anger. There was no absolution, only acknowledgement. The MG42 remains one of the most influential weapons ever created. Its design echoes in modern armies. Its principles still shape infantry doctrine. Its sound, though altered by time and technology, has never fully disappeared. But the weapon itself is only part of the story. The rest belongs to the people who lived with it, before, during, and long after the firing stopped. In the end, the MG42 did exactly what it was designed to do. It solved a problem. The cost of that solution was paid by those who stood on both sides of the gun, and that cost did not end in 1945.